All right, welcome back, everyone. Today we're going to talk about the introduction of polynomials. So in this section, you're going to learn the definition of a term and a coefficient. You'll learn the definition of a polynomial and what the degree of a polynomial means, the definition of a monomial, binomial, and trinomial, how to evaluate polynomials for given values, and how to simplify polynomials by adding like terms. So remember from section 1.8, right, a term is just a mathematical component that contains a numerical part and a variable part. Right, so we've just got some examples of terms here, 8x squared minus 4y, 12z cubed. In these terms, the numerical component is known as the coefficient. So the coefficient of each of these, for 8x squared, the coefficient would be 8. For negative 4y, the coefficient would be negative 4. And for 12z cubed, the coefficient would just be 12. So what we call a polynomial is just a finite sum of terms with real number coefficients and whole number exponents. So here, in this example, we want to determine the coefficients of each term in the polynomial. Well, here we have the terms listed for us on the left. Remember that the coefficient is just the numerical part. And so if we have 4x to the fifth, then the coefficient will just be 4. If we have minus 3x squared, the numerical part of that is just negative 3. 10x, the numerical part is just 10. And for minus 2, the numerical part is just negative 2. So remember that the coefficients are just the numbers that are in front of the different terms. So what we call the degree of a polynomial refers to the highest power of the polynomial if there's only a single variable. So for example, the polynomial negative 3x to the fourth plus 2x cubed minus 9x plus 12, that would be a polynomial of degree 4, because the highest exponent, the highest power of the polynomial is 4. The degree of a polynomial is always given as a whole number. We would just say the degree is 4. If there's more than one variable, then the degree of the polynomial is just the highest sum of the powers. So for this polynomial here at the bottom, a cubed b to the fifth minus a squared b squared plus 2ab minus 7, this would have a degree of 8, because we would add the exponents of a cubed and b to the fifth. That'll give us a degree of 8. So the degree of a polynomial is either the highest power or the highest sum of the powers. So we also distinguish polynomials by the number of terms that they contain. So a monomial has exactly one term, something like 9x to the fifth. A binomial has exactly 2 terms, negative 3x plus 5. And then a trinomial has exactly 3 terms, 4x squared plus 3x minus 2. And so for this example, we want to find the degree of the polynomial and then determine if it's a monomial, binomial, or trinomial. Well, the degree of the polynomial is just the sum of the highest powers, the highest sum of powers in each individual term. So for part A, the highest power is 5. So here, the degree is 5. And there are 1, 2, 3 terms. So this is a trinomial. For a second example, we have 4x squared y. Well, that's x squared y to the first. If we have more than one variable, then the degree is the sum of the highest powers, or the highest sum of powers. And so here the degree would be 3, 2 plus 1. And then since there's only one term, this is a monomial. And then finally, for the last example, 2x plus 5. Well, this is 2x to the first power. So the degree, the highest power, is just 1. And since there are two terms, it's a binomial. So whenever we want to evaluate a polynomial for a given variable, we simply just want to replace the variables with whatever number we're using. So we want to solve for x equals negative 2. And here's our polynomial, negative 3x squared plus x minus 1. Well, what we're going to do is we're just going to replace all of the x's with negative 2 and then simplify. It's exactly like what we've done before evaluating expressions. Now we're just evaluating polynomials. Just replace the variable with the number that's being given to you. So we want to find the value of this polynomial when x is equal to 1 or when x is equal to negative 3. So we'll start off with a. Our polynomial is negative 2x squared plus 9x minus 5. And we want to let x be equal to 1. So first, we can just take out all of the x's and replace them with parentheses. And then we're going to substitute 1. Remember your order of operations whenever you're dealing with problems like this. Exponents before multiplication. And so 1 squared is 1, so we get negative 2 times 1 plus 9 times 1 minus 5. And so that's negative 2 plus 9 minus 5, which should give you positive 2. For part B, we want to do the same thing, except now x is equal to negative 3. And so we're just going to remove x and replace it with parentheses. And then we're going to plug in negative 3. Once again, remember the order of operations. Negative 3 squared is positive 9. And that's going to give us negative 18 minus 27 minus 5. Should be negative 50. And so when you want to evaluate a polynomial for a given value, just replace the variable with that value. So whenever you simplify polynomials, you can simplify polynomials by just adding like terms. Remember that like terms are those that have the same variables and the same exponents. They don't have to be in the same order. So for example, 2x squared y and 4yx squared are both like terms. They have the same variables raised to the same exponents. They both have x squared, and they both have y to the first. It doesn't matter that they're ordered differently. Remember, order of multiplication doesn't matter. So we can still add these like terms together. And remember that when you add like terms, you're just adding or subtracting the coefficients, and the variables are going to remain the same. So here we want to just simplify by adding like terms. We have 9x cubed plus 3x cubed. Well, they both have x cubed, and so they're both like terms. So we can say 9x cubed plus 3x cubed. We're just going to add the coefficients and keep the variable the same. So 9 plus 3 is 12, x cubed. For the second example, we've got two sets of like terms, 12s and 3s, and negative 8 and 5. And so we're just going to add up only the like terms. 12s minus 3s is going to give you 9s. Negative 8 plus 5 will give you negative 3. So this thing is equal to 9s minus 3. Because 9s and negative 3 are not like terms, we can't simplify this any further. So you can use other properties, like the distributive property, to simplify expressions. So we want to simplify this problem first by distributing, and then we're going to add our like terms. So we have 3 times x plus 2 plus 4 times x minus 3. We're going to distribute the 3. 3 times x is 3x plus 6. Distribute the 4. 4 times x is 4x minus 12. And now we can add our like terms. 3x and 4x, that's going to give 7x. And 6 minus 12 will give you minus 6. And once again, because 7x and negative 6 are not like terms, we can't simplify this any further. So another example, we want to simplify by just adding like terms. We've got negative 3xy plus 12x squared y minus 9yx plus 4yx squared minus 15. So first we've got to identify what the like terms are. Here we have negative 3xy and negative 9yx. Remember that the variables don't need to be in the same order. They just need to be the same variables raised to the same power. Well, there you have x to the first power and y to the first power. And so those are like terms. And so we can just kind of set those off to the side. Negative 3xy minus 9yx plus, here we have 12x squared y and 4yx squared. Again, the same variables raised to the same exponents. They don't have to be in the same order. And so 12x squared y plus 4yx squared, and then minus 15. And now we just add the coefficients and keep the variables the same. Negative 3 minus 9, that's negative 12 xy, or yx. 12x squared y plus 4yx squared, well, 12 plus 4 is 16, and then minus 15. So remember that in order for them to be like terms, they have to have the same variables raised to the same exponents. So at the end of this lesson, you should be able to identify the coefficients of terms and determine if a polynomial is a monomial, binomial, or trinomial. You should be able to evaluate polynomials for a given value and simplify expressions by adding like terms.